Welcome to the assembly section. We are going to assemble a subcomponent of the complete part together. This component will be located in this area along with its various parts and the rotation of this gear wheel. Here I'm showing you the final result of our assembly with the subcomponent. The first thing to remember when assembling is to make sure that all the parts are loaded into a folder so you can easily add them to your assembly later. So be sure to upload your parts into Fusion. To do this, click on Upload, then click on Select Files and locate your parts on your computer. Once done, they will be added here and you can click on Upload. All your parts should now be listed here. Before starting the assembly process, I recommend opening a new design by clicking on the plus arrow. This will open a new window. Make sure to display the origin and save your design immediately. By default, your design will appear in the folder that is open on the left, which is your assembly folder. Now I have my design here. First, let's import a part together. There are several options for this, but the simplest is to click on the part and drag it into the scene. This is a configuration file, so as we've seen together, it's a part created using configurations. Therefore, it asks you to choose which configuration you want to use. In this case, we only have one option, so I'll confirm this choice. Here's my first part. The very first step when importing a part is to position it in space. Now the Move and Copy menu allows us to move the parts. Since this is my first part and it's well positioned related to the origin of my drawing, I won't make any changes, so I'll click OK. The second thing to note is that for this part, related to the origin, you have the parts folder name here. Here you can see the name of my assembly. If you look here, you'll notice some small icons. These are what we call components. This is the configuration one, component of my part. If I expand this component, I can see the origin and all the construction details of my parts here. The second element is this small anchor here. This anchor allows me to lock this part in this assembly. This means that if I click on it and move my mouse, I won't be able to move the part. It is completely locked in my main assembly, so it won't move. This is what I want. I want my first part to be the base of my assembly. Now, let's move on to the second part. We'll take this part here. And I'll click OK. As you can see, this part was designed with the same origins, so the parts overlap. This makes positioning them relative to each other a bit tricky. That's why the default Move menu is very useful. I'll simply move the part up by clicking on the arrow to offset it from my assembly. This is just to better see the part. If you look here, the origin of my parts is displayed. That's normal. It's shown here. I can hide it to simplify things. The idea is to position this part relative to the other. For this, you have a menu called Assemble. When I open this menu, I see different types of assemblies. The most common and widely used is the joint assembly. I'll click on it. The first thing you need to do is select the part you want to move. In my case, it's the parts I just added here. When I hover over a face with my mouse, the face is highlighted with reference points that I can snap to. Okay, if you look around my cursor, you'll also see a circle. This circle defines the orientation of my assembly reference related to the next part. You can clearly see that I'm selecting the face that will attach to another face. lightly on the top surfaces. Each time it tries to select reference points where it can attach. What I'll try to do is use the center of this circle as a reference point. Notice that by clicking and hovering my mouse over the circle, it automatically selects the only valid point of influence, which is the center of the circle. I'll click to select it. Now my part is grayed out, indicating that I no longer need to select it. I'll move it to my target part. So, I've selected the center of the circle, which I will now align with this other circle's center. Similarly, I select the edge, and the two parts automatically align with each other. You can see that my first selection was in the first part, and my second selection was in the second part. At any time, I can redo my selection by clicking on the cross and reselecting another point if the first was incorrect. This is exactly what I wanted. The second step after selecting the reference faces is positioning the parts. It is always possible to move the part relative to its reference faces. We'll see how it works later. Once the parts are positioned, if I'm happy with their alignment, I can define the motion between the parts using the Motion tab. Here, I can either set the parts to be fixed relative to each other or allow movement between them. I can define the type of movement, such as rotation, translation, and so on. Each time, Fusion offers a simulation of the movement, and I can choose the axis along with the movement will occur. For now, these two parts are completely rigid, meaning that in my assembly, they won't move relative to each other. That's why I select Rigid Motion. Now I see my joint appear between these two parts as a rigid joint. Next, I'll import the following part, which is the small connecting piece. I'll import my next part, which is this shaft. I'll drag and drop it into my design. I'll confirm the configuration of this part. And again, I'll offset it to better see the part and to position it. I can also hide the part's origin. I'm going to position this part within the empty circle here, where another part will be able to rotate inside the circle. The first step is positioning. We'll define the motion afterward. I select Joint and choose the top surface. Here again, you see various options. It is important to position yourself correctly. The easiest way is to choose the center so that the center of the cross aligns with the center of the circle. I'll select the edge and click. Now, my shaft is positioned. I want to move it slightly so that it sticks out in front, allowing me to position the gear later. I know that my parts are 8 mm thick and I have two parts. So I'll move the shaft along its axis, which is here. I'll look at the Z-axis and move it 16 mm, or rather minus 16 mm to ensure it's in the correct direction. By typing minus 16 mm, the part is positioned correctly. Now I'll define its motion in the Motion tab. This part is no longer rigid but will rotate. I've selected the Z-axis, and I would have immediately noticed if I had chosen the wrong axis, as Fusion would have done something like this. So the Z-axis is correct. What I can see here is that I have a reference for my joint, which is different from a rigid joint, because this one is a rotational joint. I'll continue with my assembly. I'm going to import the small connecting piece that allows me to space out my gear. I offset it slightly to better select it. I click on the Joint tab. Now you see the idea is to have the center here, the center of the square. But when I move forward, either I select the faces and can't select the center, or if I select the face, you see, I'm offered a central point, but when I go to select it, the point disappears. To keep the point displayed, you need to position the mouse over the face you want to use as a reference, hold down the Ctrl key to lock that selection, and then go find the point in question and click on it. I've selected my point, and here I select my central point. The piece will then position itself on this axis. However, the pin is positioned in the wrong place. I want it to be against this piece here. I know that I offset my axis by 16 millimeters, so I will move my piece by less than 16 millimeters to ensure it sticks to the part here. The second thing is to define the movement. Currently, I have a rotational movement. If I click on Preview Motion, indeed, it rotates. This isn't possible. Given the shape of this pin, it cannot rotate relative to my axis, okay? This piece is rigid on my axis. The entire axis will rotate, but the piece itself will not move relative to the axis, so we have a rigid joint. I validate my limit. Now my piece is positioned. I will add my last piece, which is the gear. Again, I will offset it slightly. I click OK. Same principle. I click on Joint, go to the center. Here I need to find the central point, but I can't. So I go to the face, hold down the Ctrl key, keep holding Ctrl, and click on the central point. I select the end of my axis, and the gear positions itself. Now I have two choices. Either I can offset it by the thickness of the gear to ensure it is correctly positioned, or since I've selected faces, sometimes I want it to be reversed. For that, there's a small menu here called Flip. If I click on it, I reverse the selections, the faces, and the orientation of the faces so that the two faces are then aligned in the same direction. This is exactly what I want. I click OK. So now I have my gear, and if I look here, it rests on my connecting piece, which in turn rests on the piece fixed to my housing. The gear is in a rigid joint with the axis, which is normal. The axis itself is in a rotational joint with my housing. This means that if I select a point on the gear with my mouse and move the mouse, the gear will rotate because it is connected to the axis. If I change my view slightly, you can see that the axis here, everything turns at the same time. When you manually move parts like this, a small menu appears here, giving me two choices. Either keep the proposed new position or revert to the reference position. Here, I can click on Revert to Reference Position, and it returns to the position created during the assembly. Your assembly is complete. Don't forget to save it.